this. Okay, so the first question we had gave us dy over dx equals negative 2x over y, and it asked us to draw a slope field. Make sure you're listening to all of the specific things I'm saying as I go through how the points work here, because a lot of you will make an assumption about how it works, and then maybe you actually got different points than you're awarding yourself. Okay, so we talked about this a little bit. You need to find the slope of each of those points. You need to draw a small line segment that has that slope at each of the indicated points. You should not have any line segments drawn on the x-axis because there were not any points on the x-axis drawn. So make sure you have that correct. This is worth 2 points. This is actually what our rubric looks like. So this is worth 2 points. In order to get the second point, you have to have gotten the first point. So you should have a 0 slope all along those 4 points shown on the y-axis, nothing at the origin. If you included something at the origin, you now have 0 points. If you've included anything on any additional points, you have 0 points. Okay, so you should have zeros slopes along that y-axis. You should also not have like arrows or little dots or anything like that. You can go ahead and give yourself a 0 if you've done that. All of that is unnecessary. Again, I don't care what square you get. I'm not going to ask you. This is for your benefit to know how these points are going to work. Okay. There are 1, 2, 3, 4, 5, 6, 7, 8 additional slopes. The second point is for all of those other slopes, provided you got the first point. So you have to get the point even to be eligible for the second point. So if I've already said stop grading or 0 points, or you didn't get that first one, you cannot get the second one. In order to get the second point, all of those slopes need to be correct. You'll notice that some of the slopes are the same, like in the first and the third quadrant or the second and the fourth quadrant. Make sure you're careful to pay attention to whether or not they're positive or negative. In my period 1 class, someone asked about like, can we draw additional dots, for example, to make sure that we are connecting our lines to like the right slope? So something like this, I forget what the slopes are here, but yeah, that's fine. Just make sure you're going back and erasing anything that's not part of your slope field later. So like we talked about in class, those dotted lines connecting to nearby points is pretty helpful. If you don't have a nearby point, you can create one and draw a dotted line so that you know that you have an accurate slope. Just make sure you're erasing everything except for that small line segment at the end. 2 points possible on part A. Go ahead and give yourself a score out of 2. Any questions on part A? Please unmute yourself if you have any questions.
Miss Tasha?
Yes, sir.
I'm just curious, if there were to be a point on the x-axis, how would you draw something with no solution? Because it had 0, it would have 0.
Technically, it would be a vertical slope, right? Because an infinite slope is a vertical slope. But they won't even ask you to draw something that's undefined. They'll never give you a dot at a place that's undefined. So you shouldn't be drawing anything there. Good question. Samson?
Yeah, just for A, do you ever show any work outside outside the line? Like, you guys do the dy or dx, the line?
Yeah, so we talked about that a little bit last time. Thank you for reminding me. Like, for example, if you're finding dy dx at 1, 1, you need to show it as dy dx with that vertical line and the 1, 1. But you're going to notice some patterns. So you don't have to show that for every single point, right? You can show it for a couple points and then use those patterns to determine. But when you are showing it, it is important that you're labeling it, okay? So that you are correctly labeling it as dy over dx with that vertical line and the coordinate shown. Good question. Thanks, Samson. Other questions?
Yeah, is that part graded, like going off all up? Because like, how many do we need to do? Do we need to like do all of them, or? So
it's not graded for points, Riley, but if you have stuff labeled incorrectly, you can get counted off. So you could lose points on this if you have it just like dy dx equals negative 2 times 1 over 1. Like if you had this is incorrect because you don't have this 1, 1 down here. And then they could count you off on the slopes for having the work wrong. But there's no requirement on how many you have to show. So there's not actually any awarded points for that work. So technically, if you did all of that work in your head, you would be still eligible for full credit. You just have to be very careful about that, because doing it in your head, if you miss one of those, right, now you can't get that second point. If you miss one of the 0 slopes, now you can't get any points. Okay, so just be careful about that. Yeah, but the work we don't care about too much on this problem, unless it's wrong, which is annoying. Okay, let's go on to part B. Part B asked us to first write an equation of a tangent line. I included these first steps up here, right here and right here. I included those only because I was on a new slide and so I didn't have them shown. You don't need to write those first two things down. Because it asks us for an equation of a tangent line, the first thing you really need to have, focus here, the first thing you have to have is this line right here. dy over dx at the point 1 comma negative 1 is equal to. You need to show plugging that in and you need to show the value it's equal to. If you just wrote dy over dx equals negative 2 times 1 over negative 1, and you don't have this vertical line 1, negative 1, I hope everyone's listening now, because some of you are looking over here and you're like, sweet, full credit. Nope, that's not how this works. I don't look there first. I stop grading the second you make a mistake. So please focus with me, okay? If you are missing this vertical line or this dy over dx portion, you get 0 points on this problem. I literally don't look at anything else, okay? If you've messed that up, if you've forgotten the vertical line, or if you haven't labeled it correctly, 0 points out of 2. If you wrote f prime of 1 or something like that, also 0 points out of 2. Literally need exactly that first line as I have it shown, the one with the star next to it. What's annoying is that's not even worth any points. Like, you don't get a point for writing that, but you cannot get any points if you don't have that. Okay, the first point technically comes from your equation of a tangent line. So they've given us our x and our y value back in our given, right? It said f of 1 equals negative 1. So those go here, y plus 1 and x minus 1. And then we found our slope, and our slope was 2. It would be incorrect to write a slope of negative 2x over y. Our slope is specifically the slope at the point 1, negative 1, which we found to be 2. This is your first point, provided you have the line above it. If you don't have the line above it, you have 0 points out of 2. Okay, so our first point is y plus 1 equals 2 times x minus 1. It's not helpful to multiply that out. It's not helpful at all. If you write it in y equals mx plus b, it actually makes the next part harder for you. So when I say leave it like this, leave it like this. That's literally what the rubric looks like, is point slope form. Y plus 1 equals 2 times x minus 1. Any questions on the first point here?
I have a question.
Yes.
What if we had the dy over dx and then the bar with the 1, negative 1 in section A?
You still need it on this one in section B.
Okay.
Sometimes for certain questions, if you have work shown in A and it applies to B, they'll give you credit for it. On this one, they wouldn't, because of the specificity of this question. I know that doesn't make a whole lot of sense right now. If you think you need it for a question, show it for that specific question would be my answer. Okay. All right, let's move on. So the next thing we're trying to do is it says use that tangent line to approximate. A common mistake I'll see from students is that they'll erase this x and they'll put in a 1.1 in place of it. If you don't have an equation like this where it's y plus 1 equals 2x minus 1, if you just immediately jumped over here to this and you don't have an equation with an x in it, 0 out of 2 points. Okay, so you need to have the equation y plus 1 equals 2 times x minus 1, and then separately, we want to see you plug in that 1.1 into that equation. Okay, couple really important things, very detail oriented here. Needs to be y, not correct if you write f. Needs to be y plus 1 equals 2 times 1.1 minus 1. Needs to be an equal sign here. The tangent line is actually equal to this value, okay? When we go back to the function is only approximately equal, but the actual tangent line is equal. From here, you can use fractions or you can use decimals. We've talked about that before. If you have a preference, go for that. I used a fraction for part of this and then I changed it to a decimal. It doesn't matter. You'll get credit either way as long as it's right. Okay, so we simplified 1.1 minus 1 to 1/10 or 0.1, however you prefer. Be careful. This line is where actually a lot of students mess up, unfortunately. Like they'll add 1 to the other side. God, you're like so good at all the calculus and then you mess up just the addition part. So be careful of that. Should be minus 1 to the other side. So we're doing 2/10 minus 1. That's not the same as 1 minus 2/10. So 2/10 minus 1 is negative 8/10. Okay, or negative 0.8. Doesn't matter which answer you choose. You could write both if you want. Okay, but just doesn't matter. This line, y equals one of those values, is not your final answer. What you have to have for your final answer is f of 1.1 is approximately, you need the approximation sign, you need the f of 1.1 here, okay? And then you can either write it as a fraction or a decimal. If you've missed that, don't give yourself points for including it. Write yourself a note to make sure you remember that you need to include that information, okay? Or maybe in a pen or a different colored writing utensil, add this line, but like don't just pretend you had it before. It's not going to do you any good. Any questions on this?
Oh yeah, I have a question.
Go ahead.
So if you use the negative 8/10, like the fractional version, like I'm assuming it's fine to just like simplify it down to negative 4/5.
Totally fine. Yep. And no requirement to do so, but totally fine to do so. Yep. Negative 4/5 would have been great too. Good. Other questions? Okay, we're going to move on. Next part is our separable differential. Again, some of you right now are probably looking at the end and you're like, woohoo, and I don't care if you got the end right. If you're missing anything along the way, it's wrong. Okay, so let's make sure we understand where these points are coming from. I would give yourself points as we go so that you understand each of these steps. Okay, so again, I wrote down what was given to start. We had the dy over dx equals negative 2x over y. We were given f of 1 equals negative 1. So I always like to write that as x equals and y equals just in my work to make it easier when we substitute later. I want to go through these points together. The first step is to separate your variables, which means get all the y's on the left side, get all the x's on the right side. In order to separate, we're really just cross multiplying here. We're multiplying the y up and we're multiplying the dx up. So you should have y dy is equal to negative 2x dx. Don't worry about the integral signs there. If you don't have those, that's okay. So y dy equals negative 2x dx. If you have that, you have your first point. If you have anything else, it is a 0 out of 5. I've literally stopped grading. So if you have 1 over y dy, or you forgot the negative, or you forgot the dx, or more common, if you wrote them out of order, dy y or dx times negative 2x, I've literally stopped grading. You get 0 points out of 5. Okay. Separable differential is the most points you can get on an entire, or on any question on the entire exam. It's the most points you can get on a single question. So it's really important you don't make silly mistakes as we go. Y dy negative 2x dx. This is your first point. Okay. Questions on separate. Okay, next thing we're going to do is we're going to integrate, right? So we need to integrate both sides of the equation. So I just like to draw my integral signs in that same separate step. If you want to draw it as a separate step, you can. You just don't have to. So I always draw my integral signs in that same step. Again, no big deal if you draw them later. You have to have drawn them somewhere though. So they have to exist. So if you have another line, if you just have like y dy equals negative 2x dx, and then you draw your integral on another line, that's fine, but you need to have the integral drawn or we stopped grading. Bummer. Okay, the integral of y is y squared over 2. The integral of negative 2x is negative 2x squared over 2. You are welcome to simplify that right away as negative x squared. So you don't have to show the negative 2 and the over 2. I just did just to make sure it's simplified. Okay. You also need a plus c. If you forgot the plus c in this step, even if you included it later, we've stopped grading and you don't get the point for the antiderivative. So if you forgot your plus c, you have max 1 point out of 5. Stopped grading. From here, our next step is so if you got both of those antiderivatives correct and you got the separate step correct, you now have 2 points. Okay. The next thing we're going to do is we're going to try to isolate y. So I've multiplied the 2 over, right? So that's here. I took this divide by 2 and I multiplied it to both sides. So I got y squared is equal to negative 2x squared plus c. Again, if you wrote plus 2c, that's fine, but 2 times c is still a constant. So we're just going to leave it as plus c. And then I took the square root. So when we take a square root, we technically get a plus or a minus. If you have a plus or a minus in that step, that's okay. You're allowed to. You're allowed to have a plus or a minus there. What I suggest doing is once you plug in your initial condition, you're going to notice it needs to be the minus version And so at that step, I would go back and erase whichever one is incorrect. So you just have an equation with y equals negative square root of minus 2x squared plus c. The c needs to be under the square root. But again, in this isolate step, it's okay if you have a plus and a minus shown. It's only going to be the minus eventually, which is why I suggest going back to simplify. Okay. Now, the way that the points are broken down here is not quite accurate with our current system. This is, I think, from 2008. It's kind of old, but it's a very similar question, very similar points. So our next point actually comes in this step. So once you've isolated y, you have to do all that work to isolate y, but that's actually not worth any points. So right now we got 1 point for our separate, 1 point for our integrate. Our next point is actually going to come from plugging in your initial conditions. We need to see those actual values of x and y plugged in. So I should see a y equals plugged in, so the -1, and I should see the +1 plugged in. You should not be simplifying off the bat. This is your next point. Okay. Then you're going to go ahead and solve for c. So I got rid of the negatives on both sides, squared both sides. I got 1 equals -2 plus c, c equals 3. That's our next point. Solving for your c. Right now we have 4 points possible. Final step is to take c and plug it back into the equation that you simplified. Again, the reason it needed to be the negative is because that's the only way we could get a -1 on our initial conditions. So we have y equals the negative square root of -2x squared plus 3. This is us plugging in that 3. That's our 5th and final point. This question is worth 5 points. Any questions on any part of this?
I have a question really quick.
Go ahead.
It's when we're plugging in our initial condition to find c. I didn't show that it was -2 times 1 squared. I just kind of left it as -2 because -2 times 1 is -2, but I do have -1 outside of the equal sign. So would I have lost points there?
So Nikhil, it depends. You might have. And so that's the issue. So are the people actually grading your exams are people. They're people that are going to evaluate this. Technically, the point comes from substituting in your initial conditions. So some people interpret that as I want to see that value. Some readers might say, well, clearly it was 1 squared, so it's not that big of a deal. But they could mark you off. And so my suggestion would be always show it. Always show the actual values plugged in for 2 reasons. 1, in case you get a really mean grader. And then 2, so you don't make a mistake. Like you don't do a step in your head. It's much easier to check back later that I plugged in those values right if I can see them. So that would be my suggestion. Good question. Other questions?
Just do we have to couldn't we just leave that? Couldn't we just plug in x equals 1, y equals 1, just where y squared equals -2x squared plus c instead of having to do the square root of it?
So my suggestion there, Samson, is no, I want to see y equals isolated, because if you plugged it in here, you don't have any information about why the square root is negative. Right? If you wait until you get to this step where you had a plus or a minus, that's what tells you it needed to be the negative version. And then once you find c, you're plugging it back into this equation anyways. You're not plugging it back into this. If you left your equation as y squared equals, you don't get that last point. So no, always isolate y first. That's our 3rd step, is isolate y. Isolate y first. Okay, let's move on. Okay, next problem. So this was question number 2. dy over dx equals y minus 1 over x squared. The first question was to draw the slope field. Same process as before. The first point is going to come from the most basic slopes. So in this case, that's 0 slopes. Okay. The second point comes from all the other slopes. So you'll notice here, there are 1, 2, 3, 9 slopes possible. At y equals 1, you should have 0 slopes. You should have no slopes shown on the y-axis, but you should have at 0 slope in that y equals 1 spot. You should have positive slopes on when y equals 2. You should have negative slopes when y equals 0. Okay, and those are not all the same slope. So I think this slope and this slope are the same, and this slope and this slope are the same, and then these slopes are different. Some students end up making the slopes on the end here too steep. So maybe you've messed up, or they messed up positive or negative. So be careful of that. First point comes from these middle slopes. All of those have to be correct. Second point comes from all other slopes, have to be correct. Sorry, my dog is getting into stuff. Questions on slopes? Okay, part B. Ooh, this is a fun one. Get ready. I hope you're ready for this one. Get your red pen out and ready to go. First thing we need to do is separate our variables. We have dy over dx equals y minus 1 over x squared. To separate our variables, I should be dividing y minus 1 over, and I should be multiplying dx up. I like to show this as 1 over y minus 1 dy and as 1 over x squared dx. But it's totally fine if you wrote dy over y minus 1, that's fine. Or if you wrote dx over x squared, that's fine. Okay. First point is if you separated them correctly. Again, if you have the dy first, 0 points out of 6, stopped grading. This one's worth 6 points. If you wrote the dx before the 1 over x squared, 0 points, stopped grading. It's totally fine also if you wanted to write it as like x to the negative 2 off the bat. If you wrote as x to the negative 2 instead of 1 over x squared or instead of dx over x squared, that's fine also. Just the dx has to come later. Okay, so our first point is from our separate. The next thing we need to do is we need to integrate both sides. So again, I like to show those integral symbols on that same step. You're welcome to do it as a separate step. You need to have them somewhere. Okay, so now we're going to integrate both sides. On the left side, technically there's u substitution. So I encourage you to do the u substitution off to the side, like I did over here in blue. So I did all of that u sub for that left side integral off to that side in blue. So I got u equals y minus 1, du equals dy. We get the integral of 1 over u. That gives me ln of the absolute value of u. We got to plug in our u back in. We get ln of y minus 1 with absolute value around it. Okay. Do you have to show the u sub? No, technically you don't. It's not worth its own problem. Nikhil, don't get too excited. Most of the time, if you skip the u sub, you're going to make a mistake. And then you're going to lose potentially 4 points out of 6 because you were too lazy to do the u sub. And guess what? U sub is all over the test. So if you hate u sub, that means you need to practice u sub. That's all that means. It means you need more practice on u substitution. So don't skip it. Okay, I will expect to see that u sub for all of these problems. Don't leave a comment in the chat because I'm not checking the chat. What does bars even mean, Carlos? I don't even understand your comment. Lol. Oh God. Okay. Questions? Show your u sub. We end up getting ln of absolute value of y minus 1. You'll notice on this problem, we have 2 points for the antiderivatives. Here's how that works. Make sure you're focused. I know I lost some of you because we got silly. That means you get a point for the antiderivative on the left side. So that's ln of absolute value of y minus 1. Let's say you forgot the absolute value. You don't get the point for that antiderivative on the left side if you forgot the absolute value, but you could still get the point for that integral on the right-hand side. But then we would stop grading after that. Okay, so those are 2 separate points. 1 point for separate and then 1 point for each antiderivative. If you forgot the absolute value on the left-hand side, you don't get that point. If you forgot the plus c on the right-hand side, or you've messed up that integral, which again is right here, x to the negative 1 over negative 1, or the same as negative 1 over x, plus c. If you've messed up that integral or you forgot your plus c, you cannot get that side, and then we stopped grading. So if you forgot a plus c and absolute value, you have max 1 point. Okay. Right now, there are 2 points available from this step. So 1 point for separate, 2 points, or essentially, I guess I should say 1 point for each side. So right now we have 3 points. Any questions on this? Okay, here's where it gets actually very tricky, and a lot of students are likely to stop getting points correct from here. So you need to now exponentiate. We need to isolate y. So in order to isolate y, we need to exponentiate both sides from a base e. So we have e to the ln of absolute value of y minus 1 on the left, and then we have e to the negative 1 over x plus c on the right. If on the right-hand side, you also have an e to the c here, that means we stopped grading because that is incorrect. You are not exponentiating individual portions. You are exponentiating this whole right side. You're welcome to use parentheses if you want, okay? But yeah, if you included this, then you have max of 3 points, stopped grading because that doesn't make sense. Okay, from here, Yes, go ahead.
So if it included it, but like times e to the c, and then turn it into c, would that be correct?
That's fine, Carlos. So if you included an e to the negative 1 over x, and then you have times e to the c, that's fine. But it is still wrong if you have an e shown here, because what that shows is a plus e to the c, which would be wrong. Does that make sense, Carlos, on the difference? So yeah, it's fine if you include the times e to the c part. It is wrong if you included an e here though, and I would have stopped grading either way, even if you did the next step right.
Really?
Yeah, no problem. Okay, I skipped over the step that Carlos just said. So we talked about this in class that you're doing like times e to the c. I skipped over that whole thing and skipped right to c times e to the negative 1 over x. Guys, make sure you're focused. I'm not doing this for me. I already know how to do this. Okay, so make sure you're focused and getting as much as you can out of this. So yes, go ahead.
If we didn't like exponentiate, if we didn't do like e to the ln, but we included the y minus 1 equals ce, do you stop grading at that point? Or
So sorry. Can you put him away? You don't need the exponentiation step. If you have the next step correct, Dominic, that's fine. So I think what you're saying is if you skip to this step, but you didn't show these e's at all, that's okay. That's fine. I would recommend showing them, but you don't need to. Okay, any questions on that? Okay, all right. The very next thing we're gonna do is, like I was saying, I skipped to this step. This should be c times e to the negative 1 over x. Okay, it should not be e to the negative 1 over x plus c. That's incorrect. You can go ahead and stop grading. Okay, but it should be c times e to the negative 1 over x. If you're confused how I got there, there's another video on Classroom or on YouTube that explains in the differential equation how we got to c times. Okay, but it should be c times at this point. We still are isolating y. That's still the whole step that we're working on. It's not worth points to do all this stuff, but there's a way to miss points if you mess it up. So to isolate y, we need to add this 1. For some reason, that's a step a lot of guys forget. Like they'll just write y equals ce to the negative 1 over x, and they'll forget the plus 1. So just be cautious there. Make sure you're isolating your y. You get y equals ce to the negative 1 over x. From here, some students find it really challenging to solve for c. Right? So we're plugging in our initial condition. That's our next step. So I plugged in a 0 for y and a 2 for x. So we get 1 point for plugging in our initial condition. And then we get 1 point for solving for c. To solve for c, I subtract 1. And I have negative 1 equals c e to the negative 1/2. To solve for c, all you're going to do is divide by e to the negative 1/2. So look up here really quick. I want to make sure you guys are okay with this. If you left your c like this, that's fine. You don't have to simplify stuff. So if you got a c that's kind of messy, that's all right. You can take that c and plug it right back into this equation and get full credit. Okay, so if your final answer was y equals negative 1 over e to the negative 1/2 times e to the negative 1 over x and then plus 1, that's great. It's a little crazy looking, but it doesn't matter. You don't have to simplify. There's no extra points for simplifying on FRQ. Okay. Now, sometimes we have differential equations that show up in multiple choice sections. So I'm going to make sure we understand how to simplify it. But if you got that as your C, you plug that in for C, that's it. That's all that needs to happen. Okay. Now, because I have negative 1 over e to the negative 1/2, since there's a negative exponent on e and it's in the denominator, that would be the same as if I moved that to the numerator with a positive exponent, right? Like 1 over x to the negative 2 is the same as x squared. So if I have a negative exponent, I can move it to the other side of the fraction. So that's all I did to show this step. That's, let me show you here. All I did was take that e that was in the denominator with a negative 1/2 exponent and moved it to the numerator. So I got negative e to the 1/2 times e to the negative 1 over x plus 1. If you left your answer there, totally fine. That would be the 6th point also. Okay. The simplest way to potentially write this final answer, which again, you don't need to do for FRQ, but if it was an MC question, you might be expected to simplify it or at least recognize which one was equivalent, is because I have an e times an e, I can put that into 1e and add my exponents. It's the same logic as x squared times x cubed equals x to the 2 plus 3. That's all we're doing. If I have like e to the 1/2 times e to the negative 1 over x, I can make that into e to the 1/2 minus 1 over x. I can add those things together. So that's all I did for that very last step. This would be like the most simplified you could potentially get that. Any questions? Questions?
Miss Tosher,
Yes, sir.
a couple of us wrote like every time we saw like the negative e to the 1/2 is negative square root of e. Is that all right or no?
Oh, totally fine. Absolutely. Yeah. So if you made that negative square root of e, great. Or even, yeah, that would be fine. Totally. Great. Yeah. 1/2 is the square root. Perfect. No issues with that. Great question. Yeah. So I'll add another one. Y equals negative square root of e times e to the negative 1 over x plus 1. You could have moved that negative 1 over x to the denominator. There's lots of different ways to write this final answer. Not one way to skin a cat. It's a terrible phrase. Okay, let's move on. Last question is a little strange. So the last question asks us to evaluate the limit as x goes to infinity. So the limit as x goes to infinity of the function we just found. So in any way that you wrote that final function, they want you to figure out what the limit is as x goes to infinity. So I use that very last equation that I wrote down. You might copy this down if you don't have this, but I wrote limit as x goes to infinity of negative e to the 1/2 minus x plus 1. They don't expect that you know what that graph looks like. They expect you to be able to work through this kind of algebraically. So one thing I'll remind you of is if we have a limit as we are approaching some value, we're essentially plugging it in. Now we can't really plug in infinity, but we can pretend to plug it in. Like it's not a number we can evaluate, but we can see what happens to the equation for the place where we would be plugging in infinity, right? So 1 over x is going to be 1 over infinity here. So this is the part we're wondering, like what happens to this part of the equation? If I gave you 1 over 10 or 1 over 100 or 1 over 1,000 or 1 over 10,000, what you'll notice is those numbers get smaller and smaller and smaller and smaller, right? We get 0.1, 0.01, 0.001, etc. Oh, not 1 point, etc. Right? So if I get 1 over 1,000,000 or 1 over 10 million or 1 over 500 million, thousand, trillion, billion, right? We're getting smaller and smaller and smaller and smaller. So when I do 1 over infinity, really what happens is we get 0. 1 over the largest number possible would be the smallest number possible. So you get a 0 for that portion. Now, because that portion goes to 0, what you're left with is just this. Negative e to the 1/2 or negative square root of e, if you wrote it that way, plus 1. That's what you would have as your final answer. This is worth 1 point, all or nothing. They don't grade your work. They don't care what kind of work you showed. Whatever you showed to come up with that answer, they're okay with. Okay. Mr. Austin and I talk about this a lot, but like I could teach you literally every single test and every single question that we've ever had for any AP test. You are still, when you sit down, going to encounter at least one question you don't know how to do. Okay. Often it will be a question that maybe uses some calculus, maybe uses some algebra, maybe uses some pre-calc, maybe kind of a combination of all of those ideas together. But it might be a question you've never seen before. You have to be comfortable with like working through this logic. And so this logic was, what is 1 over infinity equal, right? Or what does that approximate? And what we get to is we get closer and closer to 0. So that portion of the equation goes away. 1 point, all or nothing, no matter what your work is. Okay. All FRQ questions are worth 9 points. I'm not sure if I said that, but so we've gone through 2 of those FRQs. Each of those would have been worth 9 points separately. Any FRQ is worth 9 points. The reason DiffEQ is so important is because that single question is worth 5 or 6 of those points. Any questions?
Ms. Tosher.
Yes, sir.
For C, let's say the limit was from x approaches negative infinity. Would it just be the same thing?
In this one, it would be the same thing. Sometimes if we go to negative infinity, a different thing happens. So let's just look at, like, for example, e to the x right? If I take the limit as x goes to infinity of that versus the limit as x goes to negative infinity of that, right? Well, if it goes to infinity, you would get like e to an infinity. So it's a really big number. That's infinity. But if I went to the left side, I would have e to the negative infinity, or the same as 1 over e to the infinity, which would be 1 over infinity, which would be 0. So sometimes going to the negative infinity side changes it. But 1 over infinity versus 1 over negative infinity, those are both equal to 0. Does that make sense?
Yeah, that makes sense. Thank you.
Okay, yeah, no problem. All right, let's go back to something we did last class. Change it up. Any other questions on the FRQ for DiffEQs? Okay, hopefully that was valuable. I know that took a lot longer than I was expecting it to take, but I want to go through some additional topics here. Before we jump into this, let me just stop sharing so we can change our brains for a second. Tomorrow on Canvas, I currently have that marked as like potentially we'll meet depending on how far we get through this lesson, potentially not. I've made a decision there, and here's what I'm going to do. We're not going to be able to finish all the stuff I wanted to finish today, but what I'm going to do is I'm going to record a video later today and post it on YouTube and Classroom so that you guys can watch that lesson for tomorrow. That way we don't have to meet in a Zoom class. You can watch it tonight if you want. You can get going on the homework for tomorrow, and then you have all of tomorrow to work on that FRQ. That FRQ is not due until Monday. I think you don't have homework due over the weekend. But the issue is I want you to get started on it because next week there's another Kairos, so we have more guys missing. I want to make sure we can go through some of that content before those guys are gone. So we'll try to go through this again on Monday, and then you'll have homework due next week. Okay, so instead of us meeting tomorrow, I'm going to create a video, and my expectation is that you watch that tonight or tomorrow during class, and that you spend tomorrow during class working on that FRQ with each other if you can. So even if you're at home, try to FaceTime somebody or do a Zoom call or whatever. Okay, any questions on that? I think that's going to be the best option for everybody to be able to watch the lesson and get some practice in with each other. And in general, if you ever have feedback like that's not your preference, just shoot me an email and let me know, and we can always make their decisions. Okay. All right, let's go to area between curves. So it says find the area bounded by, and we're given f of x is equal to 2 minus x squared and g of x is equal to x. And it asks us to set up but do not evaluate. Okay, so first things first, you should draw these graphs. It's actually really important that we feel comfortable drawing our graphs. So we have 2 minus x squared. That's a parabola that's opened down and shifted up 2. So I have a parabola that looks like this. It doesn't need to be perfect. Some kind of parabola. Okay, open down, shifted up 2. Everyone should be drawing this. That's 2 minus x squared, and then we have y equals x. So that's going to go through the origin with a slope of 1. Doesn't matter if your graph is perfect. Okay, and it wants us to find the area bounded by those two graphs. So we should first notice that there is not, it's not saying from x equals 1 to x equals 2 or something. So it doesn't give us where we're trying to find that, meaning we have to identify those intersection points. In order to identify those intersection points, we need to set the equations equal to each other. Even if you could do it in your head, even if you could figure out where they're equal to each other, you cannot get any points on this problem if you do not show setting the equations equal to each other and solving for your intersection points. Sometimes solving for intersection points is its own point. Sometimes it is just required in order to get additional points. Okay, so we have 2 minus x squared equals x. That's a quadratic, so it's generally helpful to move everything to one side and then factor if we can. So I'm going to move everything to the right-hand side. We get 0 equals. I'm going to add the x squared. We still have a positive x, and then I would subtract the 2. Don't make silly mistakes there. This is literally just addition and subtraction. Okay, from here we have 0 equals x squared plus x minus 2. When we factor this, we would get x plus 2 and x minus 1. Now, some of you will draw this, and I will have already stopped grading because you forgot a very small, annoying, finicky thing, which is it should still be set equal to 0. Do not forget the set equals to 0 part. Don't just show the factoring. Okay, we can solve this. We get x equals -2 and x equals +1. And those are now our two intersection points. So now we can set up our integral. what you should be writing, you should always be labeling what it is you're finding. So what we're finding is area. So you should write area equals. Ms. Toshner, can I write A equals? No, you cannot. Here's why. We're actually going to use A for other things going forward. So A is going to be taken. Can I write R equals if it's told me that the region is called R? No, write the word area. Okay, always write the word area equals if you're finding area. This is specific to FRQ. Okay, so area equals, if you guys remember, we're going to put an integral because that's how we find area. We're going to put our leftmost bound on the bottom. So -2 goes on the bottom. Our rightmost bound goes on top. 1 goes on top. And then we're always doing top minus bottom when we're taking it with respect to X, which we are in this case. So we are doing top minus bottom, meaning that curve 2 minus X squared minus the other curve, which in this case is a line, which is X. They happen to be in order in what I gave you, like 2 minus X squared and X. Don't pay any attention to that. I could put them in whatever order. It's always top minus bottom. So make sure you're doing the top minus bottom to find that area. Okay. Now from here, we only have 8 minutes left. So I am going to say we're going to stop at this point because it said set up, but do not evaluate. Hopefully you know how to actually solve this integral. This would be a no calculator question. So you get a lot of fractions and you'd have to add things together because your next step would be to get 2x minus x cubed over 3 minus x squared over 2. You'd show the vertical line, -2 and 1. You'd plug in all the ones, and then you'd put parentheses around that and subtract, plugging in all the -2s. Then you'd simplify and solve and combine like terms into a single number. Okay, this again would be no calculator. So it'd be a lot of adding and subtracting of fractions, but that's an expectation on this exam. Just for the purposes of time, we're not going to do that here. Okay, are there any questions on how to find area between curves? Find intersection points. Go ahead, Kevin.
Why would the parabola be the top one?
Because it's above in the region that we care about. So this is the region we care about right here. And so the 2 minus x squared is above the y equals x line. Okay, if, Kevin, we were over here, for example, like if it asked us to go from here to here for some reason, then the line would be the thing on top. So it's not always one or the other. It just depends on where we are. It didn't tell us from a certain point to a certain point. It just said the area bounded by. And so that means we're using the intersection points and just finding the area that's enclosed in those intersection points. And so, yeah, the parabola is the thing that's on top. Good question. Other questions? Okay, we're going to start a new topic. That's a really hard topic, maybe the hardest topic. And then I'm going to make a video and you're going to watch it later. And this is going to be where we lead off for our FRQs. This topic is called volumes of revolution. This is important, very, very important, and very easy to mess up and kind of a long equation and kind of confusing and hard to picture. Okay, so I hope you're all excited. What I would write down is exactly what you see on the screen right now, volumes of revolution. We have volume equals pi times the integral from a to b of big parentheses squared minus another big parentheses squared and then a dx. Usually if we were in person, I would have a prop a little bit to explain what's happening here. Not going to have that. I think I'll probably, in addition to sharing my video, share a video that kind of shows you what's happening in these volumes of revolution. But essentially the idea for a volume of revolution, right? We've talked about finding area. So area is in a 2D plane, right? So we found the area of under a graph, or we found the area between two curves. Those are some areas that we found. What we're talking about in volumes of revolution, that word revolution means revolve. We're actually going to take that graph and we're going to revolve it around something. We're going to take it and we're going to like spin it around something. And that's going to like leave a trail, if you can imagine, that's going to create a shape that has a volume to it. Okay, so we're talking about a volume created by the revolution of a graph. Okay, this is the structure or the bones of that revolution. And what we're going to put inside of those parentheses is not going to make sense yet, but I'll show you an example, is R out, meaning our outer radius, and then R in, which is our inner radius. You're like, what's the radius? Well, radius has to do with a circle. So if you imagine something being rotated, right? If you look at it through this direction, so if I have something and I'm rotating it this way, and then I look at that through this direction, well, then you get a circle, right? That's now the thing that's rotating. So I get a circle. So I'm talking about an outer radius. So from wherever I'm rotating to the furthest away point, that would be an outer radius. And then an inner radius would be from wherever I'm rotating to the innermost point. Okay. Again, it'll make more sense with examples, but this is a hard topic. This is the first question we're going to do. So this says, find the volume of the solid that results when the area bounded by y equals 2x and y equals x squared is revolved about. And we're going to revolve it around a bunch of stuff, and that's going to be the videos that I'm going to post later today. First things first, we should draw the graph. Y equals x squared looks like this. Y equals 2x. It's just a graph like this. Okay, so that region that's inside of both of those, that's the region I want to rotate. I first need to find the intersection points, just like we did before. I'm going to find those intersection points by setting the equations equal to each other. 2x equals x squared, 0 equals x squared minus 2x, 0 equals x times x minus 2, x equals 0, x equals 2. Okay, then we're going to set up the bones of our equation, meaning we're going to write volume equals, we have a pi that's out in front, an integral, and then something squared minus something squared. And in this case, we're going to do dx because everything's in terms of x. We'll talk about when to use dy. Okay, always, 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 if you're talking about rotating something around something else or revolving something, always write this down first because this is going to help you get points. Okay, make sure you have parentheses something squared minus parentheses something squared. Now to fill this in, we found our bounds. So our bounds are going to go from 0 to 2. The next thing we need to figure out is what goes in for our outer radius or our R out. The way that you find your outer radius is you put your pencil on the thing you're rotating it about. So we're rotating it about the x-axis. So I'm going to put my pencil on the x-axis, and then I'm going to draw it to the furthest away curve. So my outer radius is the distance from the thing I'm rotating to the farthest away curve. I actually want to know what that distance is. That distance in this case is the distance from the x-axis to y equals 2x. So it would just be 2x. That would be my outer radius. My inner radius, again, I'm going to put my pencil on the thing I'm rotating it about, the x-axis in this case, and go to the closest function and find the distance from that to the closest function. In this case, that would be x squared. Okay, volume equals 0 to 2 times that pi, the integral of 2x quantity squared minus x squared squared. I know we're out of time. This alone, just writing this, is often worth 3 points. Okay, it's a lot of points without having to solve a whole bunch of stuff. I'm going to stop us there because I think the bell just rang. Sorry to go a little bit long today. Again, no class tomorrow. I will post a video later today. Make sure that you watch that either today or tomorrow during class, that you work on the FRQ during class with classmates. Otherwise, I will see you guys later. Be safe, make good choices. Have a good weekend.
Thank you.
Thank you.
Thank you. Ms. Toshner.
Yes, sir.
So I had a question about 2C on the FRQ.
Okay.
So the way I approached the problem was like I turned the function into like negative square root of e over e raised to the 1 over x. And then I put it infinity. So I thought it would be like a negative number over an almost 0 number. So then I got the limit as like negative infinity, and I don't get like why that would be wrong. Like I get how the other one's right, but
yeah, so you still Drew, it sounds like you have, let me just make sure. So you have negative square root of e over e to the negative, or no, e to the 1 over x in your denominator. Is that right?
Yeah.
Okay. So e to the 1 over x, when you're evaluating that, that's e to the 1 over infinity.
Okay.
Right?
Yeah.
Okay. So e to the 1 over infinity is still 0.
Okay.
So then you get e to the 0, which is just 1.
Okay. All right. Okay. That makes more sense.
Does that make sense? So 1 over infinity is not infinity. 1 over infinity is 0. And so if you have e to the 1 over infinity, right, you have e to the 0, which is 1. So your denominator is 1. So again, that part just goes away.
Okay. I just thought of it as
that way is fine also, right? You got to be careful of that algebra, but your approach is fine.
Okay. All right. Thank you. That makes sense.
Okay, great. Sounds good. See you later.
Bye.